Hello everyone. In this lecture, we want to learn how to solve a system of linear equations, but not by graphing method, but instead by some sort of algebraic method. There are many algebraic methods out there. One of them, which is a famous method, is called substitution method, and that's the focus of this lecture. So we want to solve a system of linear equations by the algebraic method of substitution. That's the goal of learning in this lecture. So, like always, we have two equations, okay, in our system. I call the first one equation number one, the next one equation number two. In this substitution method, we follow a standard procedure. The procedure is this. We find one of the unknowns in terms of the other, and then substitute it in the next equation. As simple, as short as it is. So you can find either x in terms of y, or you can find y in terms of x. Doesn't matter. You can do either way. And then when you find x in terms of y, in the other equation, instead of x, you're going to substitute that expression, which is in terms of y. And this way, you are basically getting rid of one of the variables or one of the unknowns, and then the rest of it would be one linear equation to solve, and everybody knows how to do that. So let's do it here. I'm going to select the first equation, okay? So I'm going to say 5x plus 2y equals negative 2. I'm going to keep 2y on the left-hand side, and I'm going to transpose 5x to the other side, and then I'm going to divide both sides by 2, so y would equal to negative 1 minus 5 over 2x, okay? So you may say, okay, what did you accomplish so far? Well, I'm going to say what I accomplished is this, that I found y in terms of x. I know that there were some fractions involved. That doesn't matter. Integers, fractions, decimals. Method is the same. So I found y in terms of x. That's all I did. Using the first equation. See? Now you could have isolated x on the left-hand side. You could have found x in terms of y instead of what I did, finding y in terms of x. That doesn't matter. But now, in the second equation, what I'm going to do, instead of y, I'm going to substitute this box. I'm going to substitute this expression of x instead of y in the other equation. That's the standard procedure I was talking about. So basically, negative 1 minus 5 over 2x, this is going to be substituted for y in the other equation. As simple as that. So the second equation would be 2x minus 3 times what? Well, 3 times y. But what is y? Y is this expression. So I'm going to substitute that, okay, in the equation. And then it says equals, right there, and then negative 16 on the right-hand side. So you see, by this beautiful method of substitution, we could end up with one equation and one unknown that any grade 7, 8 student can solve it, okay? So now the rest is just solving this equation, finding x, basically. The substitution part is finished. Okay, so let's see if we can apply the distributive law here. You know that from before, 2x plus 3 plus 15x over 2 equals negative 16. Okay, so we have 2x on the left, 15x over 2 on the left, negative 16 on the right, and negative 3 on the right. So that's negative 19, easy. Now, what is 15 over 2? That's 7.5. 7.5 plus 2 would be 9.5. 9.5 is 19 over 2. So basically, 19 over 2x equals negative 19. So here, to continue solving the equation, we will multiply both sides of the equation by 2. So 2 times left side, 2 times right side. Why 2? Well, because we had the denominator of 2. We wanted to get rid of it. So 2 over 2 is just 1. 1 times 19 is 19x equals negative 38. dividing both sides by 19 eventually will give you -2 as the final answer for x. Now, some people think game is over, but it's not, because we only found the value of x. Now we have to substitute this back either in the first or second equation to find the value of y. Because it's more convenient to use this third equation, I call this equation number 3, and the reason is very clear because I've already found y in terms of x using the first equation. So instead of bothering and plugging in -2 in the original equation number 1 and do a lot of algebra, so I just substituted in equation number 3, which is derived from equation number 1 anyway, and it's just a matter of convenience, okay? I can easily find the value of y by substituting in equation number 3. So -1 minus 5 over 2, instead of x, I plug in -2, and now we end up with y equals, now either mental math or you can use calculator. It gives you the answer as 4, I believe, because that's positive 5 minus 1, which is a 4. So there you go. I found x. I also found y. Did I solve the system of equations? The system? Yes, I solved it. Did I graph this? Like, did I solve it by graphing method? Did I graph any lines at all? No, I didn't. Did I use an algebraic method? Yes, I did. What's the name of the algebraic method? It's called substitution, okay? And what is the final answer? What's the solution to this system of equations? Well, x is -2, y equals +4. That's the solution to this system of equations. Now, I have explained how we check the solution, so I'm not going to explain it anymore, but you can refer to the past lectures. If you grab these numbers, -2 and 4, and plug it for x and y, in both of these equations, you will see that left side will equal to right side. And that means that you did an excellent job. The answer is correct. Okay, so we're going to do a question from the textbook now, page 39. So page 39, number 9a. It says x plus 3y equals -7, and 3x minus 2y equals -12. Apparently that's from the textbook. The question from the textbook, it says solve and check. All right? It's one of your homework questions. I'm sure you will do this. On top of this, you'll do another 20, 30 questions. Okay, so I can easily transpose 3y from left side to the other side, and x will be found in terms of y. So here I found y in terms of x. Why not, for a change, we find x in terms of y, so that you can see that it doesn't matter which variable is found in terms of the other variable. So I'm going to say equation number 1, equation number 2. So we start with number 1, and I keep x on the left-hand side, -7 minus 3y. That's x expressed in terms of y. So this is so-called my box. And now, in the second equation, as I did it before, so sub into equation 2. So sub into equation 2, we're going to go 3 times x minus 2y equals -12. But that x is actually this box, or this binomial, or this expression, or -7 minus 3y. So this substitution gives us one equation with only one unknown, and anybody can solve this. So -21 minus 9y minus 2y equals -12, and that's -11y equals 21 minus 12. That's a 9. So dividing both sides by -11 will give us y equals -9 over 11. So we ended up with a fraction as the answer, okay? And nothing is wrong with fractions. Nobody says that always you should get nice integer value answers. Sometimes the answer is positive, sometimes negative, sometimes it's a fraction, sometimes it could be a decimal number. Even irrational numbers are possible, okay? Now, to find the value of x, again, we can use our equation number 3. So x equals -7. minus 3 instead of y, negative 9 over 11. So that's 27 over 11, right? 3 times 9, 27. And this is negative 77 over 11. That's negative 7 plus 27 over 11. So this would be negative, let me see, it would be, if you subtract 27, it will be negative 50. So negative 50 over 11. So the final answer is x equals negative 50 over 11. You can't reduce the fraction anymore. You would if you could. You should if you could, I should say. And then y is equal to negative 9 over 11. And these are the final answers. So graphically speaking, if somebody graphs those two lines, they will intersect one another at some point A, whose x coordinate is negative 50 over 11, and the y coordinate is negative 9 over 11. Okay? I know these are not integers, but that's totally okay. You may sometimes get fractions as the answers. Okay? So this was page 39, number 9A. This was the exercise. I can check the answer back of the book, and you can check to see if you got it right. Also, you can write actually an official check. Okay, like in the past lectures, I'm sure you are going to review the past lectures multiple times, and you can write the check and make sure that these answers are actually satisfying the equation. Thank you very much for your attention, and keep practicing as much as you can. Thank you.